Section 7.2, we're going to look at quadratic applications, and most of these are going to deal with situations with geometric sort of applications. So, example 1 tells us the length of a rectangle is 3 inches longer than the width. The area of the rectangle is 108 square inches. Find the dimensions of the rectangle. So, the first thing I'm going to do here is draw me a rectangle, and I'm going to label this the length and this the width. And I'm going to look at the information I have here. I know the length of the rectangle is 3 inches longer than the width. So the length right here equals the width plus 3. So I can either call this side right here L, or I can just call it W plus 3. It also tells me that the area of the rectangle is 108 square inches. We should know the area of a rectangle. Area of the rectangle is length times width. They tell me that the area is 108, so I could plug that in here for A. So 108 equals L times W. However, I cannot solve that equation when I have an L and a W. But what we can do here is sort of like a little bit of substitution that we've done before. I know that the length is the same thing as W plus 3. So I can take this L right here and I can replace it with our W plus 3. So 108 is going to equal W plus 3 times W. Or you might prefer to write it like this. We typically see that W written first. That step's not necessary. So if I want to solve this, I'm going to distribute my W. So I have 108 equals W squared plus 3W. And notice that I have a W squared and a W here, so I'm going to have to factor. So I need to move this 108 to the other side of the equation. And whenever I do that, I'm going to get 0 equals W squared plus 3W minus 108. I need to factor this, so I know as I factor it, I will have W and W. 108. Here I could use 12 and 9, so if I have a positive 12 and a negative 9, that will factor like so. So that means that my two answers would be W equals negative 12 and W equals 9. But let's think about the context of our question here. The question is asking me to find the dimensions of the rectangle, and it would not make sense to have a negative dimension. You can't have a negative length. So I'm going to throw out this answer right here because it is negative. So my width would be 9. So what we're measuring in here, inches. And then the length is 3 inches longer than the width, so the length here is 12 inches. So this gives me both dimensions of my rectangle. Our next question, we have a banner that is in the shape of a right triangle, and it has an area of 63 inches squared. The height of the banner is 4 inches less than twice the width of the banner. Find the height and width of the banner. So we have a right triangle here. So we're going to draw ourselves a right triangle. And that right triangle has an area of 63 inches squared. The height of the banner here is 4 inches less than twice the width. So I'm going to call this width here. They're telling us that height is 3 inches less than, 4 inches less than twice the width. So height equals 2W minus 4. So my area for a triangle is 1/2 base times height, or in this case, we're calling that base a width. So let's actually say 1/2 W times H. However, we don't want to have two different variables. I know this area right here is 63, so I'm going to put that there for my A. I'm going to have 1/2 W times, and H, I'm going to replace that with 2W minus 4. So to solve this here, I will need to distribute this 1/2 W. So I'll get 63 equals W squared minus 2W. And I will need to move that 63 here over to the other side of the equation. So 0 equals W squared minus 2W minus 63. I will factor this. So W squared, I'd have to have W and W, and I believe I could use a minus 9 and a plus 7 here. So that would give me answers of W equals 9 and W equals negative 7. Just like with the last problem, we need to throw out that W equals negative 7 because we cannot have a negative length. So my width equals 9, let's see, we're measuring in inches here, so 9 inches. And the height is 2 times 9 minus 4, so that is 18 minus 4. So I get a height of 14 inches. So my dimensions of the banner here, I have a width of 9 inches and a height of 14 inches. So in this problem, we've got a rectangular poster, has an area of 190 inches squared. The height of the poster is 1 inch less than twice its width. Find the dimensions of the poster. So I'm going to draw me a rectangle here. And I know that I have a width here and a height here. So the area of this poster would be the width times the height. I also know that the height of the poster is 1 inch less than twice its width. So height is tells me to write H equals 1 inch less than tells me to put a minus 1 over here, and twice the width tells me to put a 2W. So this is the information that I have. I need to plug that into my area formula. So I know that my area is 190 inches squared. Right here for this A, I'm going to put 190 equals, and I'm going to keep my W. I'm going to replace the H with 2W minus 1. And by doing that, now I only have one variable in the problem. So I will distribute here. So I get 190 equals 2W squared minus W. I will also subtract that 190 because I need this equation to equal 0 so that I can factor it. So 0 equals 2W squared minus W minus 190. Now I need to factor, and when I factor this, I can use a 2W and a W. To get 90, I could multiply, or I'm sorry, 190, I could multiply 10 and 19, I could multiply 5 and 38, lots of different possibilities there, but I believe the one that is going to work, excuse me, is 10 and 19. I'm going to have a positive 19 here and a negative 10 here. If I check there, I get 19W and negative 20W. That gives me the negative W in the middle. That means that the answers that I would get here, 2W plus 19 would equal 0, which would be 2W equals negative 19. So W would be negative 19 over 2. We're going to throw that answer out because it's negative. Over here, I would just get W minus 10 equals 0. So W equals 10. So that is my width. My width equals 10 inches. I also need to find the height of the poster. So I would say that the height is 2 times 10 minus 1. 2 times 10 is 20, minus 1, I'm going to get a height of 19 inches. So there are my answers for example 3. For example 4, we're going to go to a 3D problem, and we're to suppose that we are building a storage box of volume 4,368 inches squared. Excuse me. The length of the box will be 24 inches. The height of the box will be 1 inch more than its width. Find the height and the width of the box. So here we have a box draw that in pretty good line. And we know that the height, or the length of the box, we'll call this the length here, is 24 inches. We know that the height of the box is 1 inch more than the width. So here's our, we'll call this the width and this the height. We know that the height is 1 inch more than 1 plus the width. So, to find volume, volume equals length times width times height. I know that my volume for this problem is 4,368 square, that should say inches cubed right there, cubic inches. And I also know that my length is 24. I know that my width is just W. And then I know that my height is 1 plus W. So what I would do here is I would distribute this 24W. So 4, 8 equals 24W plus 24W squared. I'm going to move everything to one side, so I'll get 0 equals, let's write that 24W squared first, plus 24W minus 4,368. Now, those are really large numbers, so let's check. Let's use our calculator and let's check and see if maybe we have a greatest common factor there. So 4,368, let's see if it is divisible by 24. And it is, so what I can do is I can divide everything, both sides, by 24. And that will give me a little bit smaller numbers to deal with. I'm going to get 0 equals W squared plus W minus 182. I'm looking for numbers that will go into 82 so that I can factor. I know I will have a W and a W here. So 182, if I divide it by, let's try 16. That doesn't work. 182 divided by 12. 182 divided by 4. 182 divided by 2. I know will work. 291 will not give me this here. Let's see. Let's try 14. 280. I'm sorry. 182 divided by 14. That works. 14 and 13. So I'm going to say plus 14 minus 13 here. So my two answers that I get are W equals negative 14, which we are going to disregard, and W equals positive 13. So my width is positive 13, and what are we measuring? This is in inches. I already knew that my length was 24 inches, and then there has to be one more than the width, which would be 14 inches. So here's my answer, 24 inches by 13 inches by 14 inches. If I want to check my work, I can do so pretty easily. I just need to do 24 times 13 times 14, length times width times height. I get 4,368, which is supposed to be the volume that I have here in the original problem. So I know that I've done this problem correct.